All right, welcome back, everyone. Now you know how to create VLANs. We've done the VLANs, we've assigned the VLANs, we've learned about the virtual trunking protocol, trunking ports, all that good stuff. But now it's inter-VLAN connectivity. We need to be able to, because right now they're in their own VLANs, in their own broadcast domain, so they cannot talk to each other. All right, so we're going to go inside this lab and we are going to configure in our router, and then do verification commands, obviously, inter-VLAN connectivity. I'll see you inside the lab. All right, here we are inside the lab for inter-VLAN routing. Okay, now remember what I said. Right now, there is no communication between none of these computers. They can't even get out to the internet if they wanted to, because they can't even get to their own gateway because the router has not been configured. Like I said, we're not doing layer 3 switches, so we have to actually use a router. So what we're going to do is we're going to open up the router. Now you can see the networks we have 10.0 and 20.0, but we're also going to do a default gateway for the 1.0 network. Because if you recall, let me open up this switch right here. Yeah, let's maximize it. Let me see. Let me bring it down real quick. Go to CLI, then maximizing. There we go. And you see we have a username, which is LDs. Those were based on our configuration, Cisco. All right, and then we're in privilege mode because we have level 15 privilege, which is administrative. And if we do a show VLAN, you see that we have two VLANs, 10 and 20. There's a root bridge, so they're not assigned there. They're assigned to the ones in the bottom. All right, so just so you can remember that. But if you look, see the show interface VLAN 1. You can see that we have an IP address on that particular interface, which is 1.253, and it has also a default gateway for as of 1.254. So we're going to go ahead and give that as well as a part of our inter-VLAN routing. All right, so and that's question that brings up is, well, now we have inter-VLAN routing, everybody can talk to everybody. And that's when you go to the next step, which is securing things via either layer 2 access list or layer 3 access list. All right. So let's go to our router and let's maximize that. Oh no, let me do CLI first, then maximize that. Now we're not going to do any basic housekeeping or administrative commands. We're simply going to give it a name, host name R1. All right, and we're going to go straight into configuration. Now we're in interface F0/0. That's what we're connected to. Now you don't put an IP address on the physical interface, okay? That's just, you just turn it on because you're just trying to get through it. So the physical interface needs to be turned on, but we're going to create sub interfaces for each particular network, all right? Because you're not going to have, if you have 20 subnets, you're not going to have 20 NIC cards. You create sub interfaces, all right? So I want to up arrow till I get to that interface. Now the first one I'm going to do, let's do .1. And it's not required that the number for the sub interface is the same as the VLAN that you're going to. It's not required. But I recommend it. I think Cisco recommends it because, I mean, visualization purposes. Why, if it's VLAN 1, why would you not put 1 for the sub interface? It just wouldn't make any sense. All right. So let's do that. Now, the encapsulation, encap for short, .1Q. Okay, 802.1Q, right? When we trunk the ports, that's the type of encapsulation that we're on those ports. So that encapsulation needs to be the same. Now here, the .1Q ID, that needs to be the same. The number that I put here, if it's for VLAN 1, then it must be 1, because that needs to match up with the VLAN ID. So, and then what is the default gateway? IP address, 192.168.1.254, 255.255.0. All right, now you don't need to do a no-shut because as you can see, everything is up. All right, these are virtual interfaces. So that's done. So let's just up arrow. Now the next interface we're going to do for VLAN 10. So I'm going to put subinterface 10. I'm going to hit enter twice. Let me up arrow. .1Q is going to be 10. That has to match. And then the IP address is going to be 10.254. And I'm trying to make it simple because you're trying to understand the concept, not memorize a whole bunch of IP addresses. So that is the gateway for the 10.0 network. All right. So now we're going to go ahead and do the 20 VLAN. So I'm going to make an interface or sub-interface for that, which is 20. And then the encapsulation is going to be 20. And then the default gateway or the IP address for that sub-interface is going to be 20 as well. And then we can just do a do do show IP, and brief. And when we look at that, we see that we have our physical interface that shows this up. We see our sub-interfaces .1, .10, and .20 with the proper IP address on there, and they also show up. Let me just do it from privilege mode, do a Control-Z to get there. Show IP route. All right, you see we're connected to those via those sub-interfaces. And one last check, we want to do a show start or show run, whichever you want to do. Usually in your certification, it's show run. And this is what's interesting to see, that it's going to recognize that this, since we never changed it to anything else, by default, it is the native VLAN. It recognizes that that's the native VLAN. And that's because the encapsulation is matching the VLAN ID. So that's why this number is so important that you get it correctly. Not so much the sub-interface. This is for your benefit, but the sub-interface, the encapsulation number has to match the VLAN ID. So we're good. 1 is 1, 10 is 10, 20 is 20. This is why I do it that way, to make it simple for you to understand. You don't have to be, oh my God, what was the VLAN? Was it 11? Nothing like that. Just trying to make it simple, not understanding a concept, all right, for inter-VLAN routing, for intercommunications between these particular computers. Now you can see we have a green light. It went from green to red. If you go back to the switch, and let's maximize that. Remember last time we didn't see the port 24 that was trunked? And if we do a show in trunk now, you see that change state to up, show in trunk. Now you see 24 that's on, and the 8021Q protocol is up and running. Okay, so that's one of the things that you need to verify to make sure, because remember what I said, if you don't trunk the ports, then anything other than native VLAN will not be able to get across. All other VLANs besides the native VLAN must go across trunk ports. So verify, verify, verify. All right, so let's see. Let's open up this PC right here. Let's put it to one side. Let's go to command prompt. And obviously the IP address needs to be there, so IP config. And the IP address is there. Okay, there it is right there. All right, so we're going to ping our gateway. Let's start by doing that. 192.168.20.254. And we have connectivity. Let's go to the other gateway. 10.254. Well, we have connectivity. And let's go to the actual other computer, which is 10.1. And obviously, here comes the ARP that we expect. And we have connectivity. All right, so we now have inter-VLAN routing, but the thing is, remember, VLAN 1, we want to leave it for the administrators, for the IT personnel, and that's a problem because, well, I don't have a computer there, but let's go to the interface, 1.254. I have reachability to that 1.0 network. So let me see. We did configure telnet or SSH. So let's do a SSH -L to the, I think it's the first, I always get this backwards. LDS, because we have a username and password, and then Cisco, CISCO, right? The password. No, the IP address. Sorry, 192.168.1. Let's say 253, right? That was the top switch, which is the root bridge. If I know the password, CISCO, oh, not 0. No, is it caps? CISCO. Okay. Laz. Okay, let's try it again because I forgot what password I put. Turn the caps off. LAZ. Laz. Oh, okay, Cisco. I knew there was something there. I had to think about it for a little bit. All right, so you're in, and that's a problem because now you're in with administrative privileges. You can do whatever you want. So you don't want other VLANs to maybe, you want to control that. certain VLANs access to where you need to go. But again, that'll be taught later on in the course through access list that you can control which VLAN talks to whichever other VLAN. All right, because normally the reason we create VLANs is to logically segment the network, maintain the broadcast within that VLAN so it doesn't generate or create any noise outside that, and then you have better control of security and administration to that particular VLAN. All right, but that's inter-VLAN routing. Very simple, and you can see that you can tell it where you need to go. You're inside the switch. It will work on all the other switches. So we have connectivity all the way across. Now it's just a matter of actually securing that particular network using access list, which we'll learn later on the course. I'll see you outside the lab. All right, pretty simple. All right, all we had to do was go inside the router, create our sub interfaces or virtual interfaces. All right, and put our encapsulation or create our sub interface, put in the encapsulation type to match the encapsulation of the switch, right, that particular interface, and put in the default gateway for a particular network. We did it for 3, because in actuality, we did have 3 VLANs. We have VLAN 1, which is going to be the administrative VLAN, 10 and 20, and you saw that we have connectivity. Now, I did mention that that's an issue because now anybody, if they have the password, as you saw, you can go ahead and telnet into these switches or SSH into the switches, all right, if you know the password. But you don't want that. Later on in the course, we'll talk about access lists and we'll actually control who can get where, all right? But that's later on in the course. But it wasn't that difficult. But always remember what actually all the commands that we did to make it work. And always keep in mind, the encapsulation must match the VLAN ID. The sub interface doesn't. It's just something for you, all right? It's recommended. See you in the next. Alrighty, welcome to EtherChannel. Yes, we had this in the old CCNA, but this is the new CCNA, but still it's the same thing. EtherChannel is EtherChannel. All right, what is it you need to know? What is EtherChannel? Port aggregation. That's it. You're taking a bunch of cables together, all right, and put them as one. You can do up to 8 interfaces, okay? To make it, instead of having 100 megabits per second, right, with the fast Ethernet, you can have 300 megabits per second, 400 megabits per second, all right? And most importantly, things that you need to memorize is this right here. Now, the V, the C, the CA, and the V, I put. The V means it's not vendor, it can go across vendors. It's not vendor specific, all right? So if you're running a mode when you're configuring it, all right, you're going to go ahead and it's going to be active. And that means it's going to use the aggregation control, link aggregation control protocol, okay? So, and if you use that on one side, then you got to use the passive on the other side that says, hey, are you running LAGP? Yes, then I'm going to run LAGP too, because they got to match. And that's what I say down here. The modes must match on both sides for the interfaces that you're doing, all right? If you do desirable, all right, that's Cisco. That's why I put the C there. That is Cisco proprietary. So then the other side is auto. So it can do the negotiation of PAGP. Now, if you do on, it just means there's not doing any negotiation whatsoever. But you're still creating that Ether channel group. Now, the configuration is not that big. It's right here, all right? You create your channel port or your channel interface. All right, you trunk it, and then you go inside the ports that you're going to aggregate, okay? And then you trunk those ports, you do the non-negotiate, and then you do this. Channel group 1, because that's the one you created, and then what mode are you doing? Let's go into the next lecture that's going to go inside the lab, all right, to go ahead and do that. See you there. All right, here we are. We're in the lab. They're both going to be identical, but I'll explain them when we get in there. All right, we're going to go ahead and configure this bottom one to use EtherChannel. And we'll take a look at little different commands here and there, okay? Let's get inside. All right, here we are inside the EtherChannel lab. All right, this is not something that's new to us. We heard about this. We did it in the older CCNA. Now it's still in the new CCNA. What you need to understand about EtherChannel is that it aggregates. That's its point, to bring all those 3 cables that you see there together and use them as one to increase bandwidth. All right, to increase bandwidth. And right now, what the topology we're looking at is the same thing from the top one and the bottom one. You can see that 2 ports are blocked because of spanning tree. Because of spanning tree. Okay, spanning tree is working. You see redundant links, so it's going to do what it always does. It says, okay, I need to block a certain amount of ports, so it chooses to block those 2 ports. And you see it's blocking the same ports on top than it is on the bottom. So there is no ether channel configured, and we do have connectivity. Let's see, this is the 1.0 network. Let me see if the computers have their IP address. Let's take a look. Desktop. Okay, this is 1.1. So probably the other one is 1.2. Let's see if we can ping across. Ping 192.168.1.2. And we do. We have connectivity. All right, why wouldn't we? All right, but what we want to do, we want to have faster connectivity, right? In our backbones, we want to make sure that, you know, we have just, instead of just 100 megabits per second, we have 300 megabits per second or more. You can aggregate up to 8 lines. Now, even though it's outside the scope of the CCNA, all right, just to warn you, because if you're going to do ether channel and you aggregate all these 3 cables, what's going to happen is it's going to treat it as one cable to bring the bandwidth together. But it turns all these ports to forwarding ports, and we'll look at it. We'll just look at it. Understand that that could create an issue with connectivity because they'll all be forwarding. That means that you could possibly have a switching loop. So you need to take a look at this, because maybe some ports you will need to say, hey, you know what? Let's not do, you know, the configuration. Let's not do any kind of channel group 1 mode on that particular port, because you want a port for span tree to look at to block it. All right. If not, you will have a switching loop. So be very careful. I think that's outside the scope. Basically, they just want to know what you see here on the right. Well, first of all, they want to know that you know what ether channel is, which is the aggregation of, you know, multiple cables as one. Okay. So you can have greater throughput in your traffic. Now, one of the things that you do need to understand, now you'll never see this when you look at the modes that they have. I put this in here, okay? What this means, this is vendor across vendors, basically. You can, you know, do whichever, as LACP, so it's not proprietary to any particular vendor. You can use it through anyone. Now, there's other benefits to using LACP, all right, that you can go ahead and, you know, you can read about, what have you, but understand that it's not Cisco proprietary, all right? But now, if you do active, that means that it's going to use LACP, all right, link aggregation control protocol unconditional. I mean, it's going to do it, period. This is what I want. And then you have to, if you're going to use active, the other side must be passive. That's going to say, hey, I want to go ahead and, if the other side is LACP, then I want to be LACP too. Okay, so it's not vendor specific. Or you can do desirable, which that C stands for Cisco. That is Cisco proprietary, PAGP. So if you do PAGP, then you got to do auto on the other side for the negotiation. And it says, hey, I'm going to go ahead and be PAGP as well. All right, so they got to match up on either side. Now, if you just do on, that means you're still going to have an ether channel. There just won't be any negotiation going on back and forth. That's the only difference. All right, and here is the configuration that we're going to do. It's very, very simple. So let's go ahead and get to it. All right, you know we have connectivity across, so let's go ahead. And now one of the things I like to do, because the ports that we're using is 20, 21, 22 on both sides. What I like to do, first of all, and again, this is just me, I like to turn off the ports, because I don't want anything to start sending information back and forth before my configuration is over when it comes to doing ether channel. So I'll do an int range interface F0/20, right? It was 20, 21, 22, was it? I don't even remember now. Ooh, there, 20, 21, 22, yeah. No, not maximize last. Over here. Okay. Let's open it up again. All right. 20 through 22. Sorry about that. Int range. Okay. Int range range. Oh, F, wow, okay. F0, 20 through 22. All right, I'm just gonna shut down these particular ones. All right, and I'm gonna do the same thing on the other side as well. I'm gonna go ahead and open that up. And again, I don't want anything to, start sending me any information whatsoever. I'm just gonna do int range F0/20 through 22, and then do a shut. Right, shut them down. WR. Just a force of habit I have to do that. All right, now I'll go ahead and I'll start my EtherChannel configuration. See, the ports are red because those three interfaces are down. Now, let's go ahead and start from global configuration. And what we're going to do is we're going to create the port first. All right, so we're going to do interface, port, -channel. And again, it's a number. It's a local number. You can pick one. You can see you can do six channels here. We're just going to do, there's our first ports or our first channel, so there's going to be one. And then we need to make sure that that is trunked. So we're going to do switch, port mode, trunk. Okay. Then we're actually going to go inside those three interfaces that I just shut down. I'm going to go interface, range, F0/20-22. All right. And I'm going to do, okay, we're going to trunk those ports, switch port mode trunk. All right. We are going to do switch port non-negotiate, but then we're going to give it the negotiation, which we want to. Here it says passive. All right, so that means that we're using what? A non-vendor. But let's go ahead and change that, and let's go ahead and put active, or so it can be unconditionally. It's going to not active, desirable. So we're going to do desirable. All right, so we're going to use Cisco. All right, we're going to do switch port, non-negotiate. Non-negotiate, and then we're going to do the channel group that we're in, channel group 1, what mode. And this is where if you do a question mark, this is where you see all that I have here on the right. So we're going to do desirable. Okay, turn that on, do WR. Okay, so we're okay there. Now you're not going to get any feedback because the ports are down. I'm not going to turn them on until I do the other side. So let's go to the other side. And we essentially do the same thing. We do the same thing. Control Z, we got here. Shoot. All right, and let's do config T. And we're going to do, again, interface, ports, -channel, 1, because this is our first port, or first channel port. And then we trunk that port, switch port mode trunk. Then we're going to go into that interface range. I think I can, no, I can't. Okay. Interface range F0/20 through 22. Okay. Then we're going to do switch. We're going to trunk that these ports, right? And it should be trunked automatically, but that's okay. We're going to trunk it anyway. The switch port non-negotiate, and then channel -group 1 mode. Now we did desirable on the other side, so that means we got to do auto on this side. All right. So since this is the side that's going to have to say, hey, what are you running? I'm going to turn on the other side first. Those ports, I'm going to turn those ports on first. And then when this one comes up, it's going to say, oh, hey, you're running this. All right. So I'm going to do a no shut. I'm already inside the range. Okay. Control Z. All right, let that come up, and I'm going to go to the other side and do the same exact thing. I'm going to do a no shut over there and turn those ports up as well. Control Z. All right, and you can see they're going through their process, but I'm going to fast forward in time because I don't feel like waiting. Come on, and now you see that the green lights are on. All right, all green lights are on. This is why I said that. Be careful, because you could actually create a switching loop, because now the ports are going to be fast, forwarding. So if we go ahead and let's look at switch 1. And we do show I think, whoa, what happened there? Hit the wrong button on the keyboard. Show, shift key. There it is, ether channel. Just wanted to make sure I was right. Show ether channel, and then you can say, port channel information, or just show ether channel. And you can see right here, show ether channel, group 1, group state is L2, okay? Maximum is 3 ports, okay? Ports are 3, but we have a maximum of 8 ports that we can use. Port channel is 1, okay? And the protocol that we're using. All right, we do the same thing, but this time if we question mark it, and let's open it up a little bit because everything's getting truncated, and I hate that. And then we do the port channel 1. Oops. Or port channel, okay? Now you can see what we see here. Hey, this is that is running desirable, okay? And is running on these 3 ports right here, okay? So we are running the PAGP, all right, as you can see. All right, let's go up here. Where's that? Port channel, channel group 1, okay? Port channel is PO1, all right? And it tells you how long, the age of the port channel, how long it was created. It was created 6 minutes ago, all right? The protocol is PAGP, and there is no port security. It's been disabled, or it hasn't been configured at all. We haven't done nothing like that here. But one of the things that you want to look at, if you do a show spanning tree, all right, we only have one VLAN in here. You can see that all the ports are forwarding, all right, and you can see that you have your port channel right here, all right, which is nice, okay, but still all the things are forwarding. Now this is the root bridge, okay, that's fine. We expect that on the root bridge, but not on the other switch. All right, we do here, show spanning tree. All right, you can see we have port channel 1, which is fine, and that's the cost of it right there. Okay, but again, all ports are designated forwarding, which can cause an issue later on. But again, I'm not going to get into that because it's outside the scope of the test. Just know that you see we do create an actual port for that. Okay, but all ports do turn to designated forwarding. They're now aggregated into that particular channel, so it can have greater bandwidth. Very easy configuration, all right, but once you get into a larger enterprise where you have more redundancies in your backbones, if you were to have 4 core switches and they have 2 redundant links to each one, a complete mesh with 2 links, and you've created ether channel on all these links, then that could be an issue because you've now stopped spanning tree from looking at those particular ports, because they're all going to be designated forwarding. So just keep that in mind. But for the test, this is the certification of CCNA, what we did, the configuration of it, how we did it, and the meaning of all these right here is what you need to understand as well. All right? I'll see you guys outside the lab. All right. No big deal, right? No big deal. Exactly what we saw on the presentation. The configuration, those modes is what you need to actually keep in mind. Now, you saw that we went to these interfaces, or we did the show spanning tree, I should say. When we did the show spanning tree, yes, all ports, and you see an extra port there for the port channel 1, but you see that all ports are designated forwarding because spanning tree is not looking at it. Because you see, remember the top? See how it's blocking 2 ports? Because spanning tree is saying, hey, I need to stop the forwarding to avoid a broadcast domain. I mean, not a broadcast domain, a broadcast storm. But when you do this, that means you're putting all 3. Spanning tree sees it as 1. So all ports are designated forwarding. In a larger enterprise, and I mentioned that already, in a larger enterprise, and it is beyond the scope that we need to do for the CCNA, but just for you to be aware. In a larger enterprise network, for let's say you have more, you have 4, 5, 6 core routers, you have a full mesh, all right, with 2 links, all right, coming out of each particular switch. If you aggregate all those ports, you could create a switching loop since spanning tree is not looking at it. So you may have to go in there and turn off spanning tree, okay, or turn off, not turn off spanning tree, turn off ether channel, all right, no channel group mode or no channel group 1, All right, take it out of the Ether channel because so Spanish can look at it again and say, oh, okay, let's block this one to avoid switching loops. So we looked at the different ports as well, so you can see, hey, this may later on run into an issue with connectivity. Not only a broadcast storm, but with connectivity itself. All right, so you gotta be very careful. But in something like this, very small, all right, just back and forth to understand the concept of Ether channel, so you know what the modes are, how you would configure it, what it is. This is just fine. You have connectivity back and forth. All right. Well, that's Ether channel. I'll see you in the next. All right. You've made it to the end. It was a very brief section. Two things that we talked about in there: inter-VLAN routing and Ether channel. Okay. So what do we do? All right. So inter-VLAN. What do you need to remember? The encapsulation must match the switch. So you're on your router and you're creating your sub interfaces. The encapsulation is the .1Q or ISL if you're doing that, but that's old. I don't know why you would do that. Okay, but 802.1Q must match that VLAN ID number. That is required. The sub interface or the VLAN ID, all right, okay, it's recommended. But if you're doing a sub interface for VLAN 100, why in the world would you create an interface F0 slash dot 33 if it's for VLAN 100? It makes no sense. Okay, so just put your sub interface, the number of your VLAN to make it easy for you. All right, even though it's recommended, but come on, common sense. All right, make sure you put the correct default gateway. Make sure you know the networks that you're working in. All right, so put the correct default gateway, and then verify connectivity. Always, always, always before you click that next button. Make sure you get to where you need to get to. Whatever the simulation said that you needed to accomplish, make sure you did before you click next. Okay? All right. And then we went to Ether channel. Again, we created the port channel. We chose the range of the interfaces. We trunked the ports, and then you chose your mode, right? Through the configurations. Now, you're going to have the handout that you saw in the lab, so not a big deal. But again, understand what Ether channel is. It's just an aggregation of ports. That's all it is. So you're going to increase your bandwidth, more efficient throughput throughout your network. But always, like I told you, in a larger enterprise, you may run into an issue. You may run into an issue due to the fact that all the ports are what? Designated forwarding. And you saw that on the root bridge and the not root bridge, because spanning tree is like, oh, it's only one port. So that could be an issue later on. So again, beyond the scope, but just keep that in mind. All righty. See you in the next.